Hello, cutie patootie, math angel. Welcome back. This is Decaf-Math, ASMR. Today we're going to talk about the composition of functions, how to compose one function with another, or technically, you can compose a function with itself. Before we get into the math, I wanted to send a special little shout out to our patrons over on patreon.com. These are our current patrons and a few others as well. And if you'd like to support the channel for $1 a month or more, please check out the link in the description box under this video. And I'd love to add your name or tag to this list. Thank you so much for the extra support. Now let's get into the math. I do want to say it's totally okay to just zone in and out as you please. This is not meant to be a formal math lesson at all. I hope that you find this nice and relaxing. If you happen to be reviewing this or learning it or are interested in it, I do hope that I say something helpful and encouraging to you. But just take your time and kind of see where you are in your understanding, and as always, adapt what you hear on the internet to other resources that you might have. And of course, if you know this stuff and you've learned it long ago and you're nice and comfortable with it, I still hope that this video is nice and relaxing for you. So I think it's easiest to look at a direct example first, to look at the big picture pattern. Then we can kind of chat a little further, okay? So, as I said at the start, we need two functions, or we can compose a function with itself, but the idea is that we need to have two functions to work with. Since usually you learn about this idea of composition in algebra, I'm going to use classic functions that you learn there. So no trick functions yet, or anything too complicated. So let's just start with maybe this function. I'll just make up something here. And how about something like this? Okay. So the first thing is, how do we read this out loud? We have f of x equals x cubed, or x raised to the third power. And we also have g of x equals x plus 2. So we have a cubic function and a linear function. So first thing is, we kind of need to understand what a function is. And I do have some videos in the pre-algebra and algebra playlist that refer to this concept, but let's review it briefly here. So for f of x equals x cubed, this basically tells me that if I give you an input for x, a specific value for x, this tells me what to do with that input to give me a corresponding output. So this says, take that x thing and cube it. Okay, so if I give you 2 as an input, then the output is 2 cubed, which is 2 times 2 times 2, which is 8. So you would say f of 2 equals 8. So an input of 2 gives me an output of 8. An input of 1 gives me an output of 1 cubed, which is 1. An input of negative 3 gives me an output of negative 3 in parentheses cubed, which is negative 27. So I hope that you get the idea. F of stuff is stuff cubed. So it doesn't matter what this input is as long as you pick allowable values. So you can't go breaking math, but if I you f of heart, that gives me heart cubed. Okay, so that's the general pattern. Same thing for g of x. We just have a new set of instructions here. If I give you stuff, I just get stuff plus 2 as an output that corresponds with each input. So g of -1 equals -1 plus 2, stuff plus 2, which is positive 1. G of 7 equals 7 plus 2, which is 9. So I hope that you get the idea there. G of heart is heart plus 2, f of heart is heart cubed. So it's just a set of instructions. Okay, that's all that we really need for today's concept. So, of course, there's much more to study about different types of functions, parent functions, their graphs, and all that stuff. But I think that's enough for today's concept. So, the idea of composing two functions, like we said, is to take one function and put it as an input into the other function. So usually, notation-wise, you'll see something like this. Perhaps something like this. I'm actually not really a fan of either of these, but I'm writing it because it's common. And instead, I like to write f of g of x like this. But they're all read as f of g of x, f of whatever. So, in this case, what this means is I start with this innermost function. I have g of x. So let's just work out this example here. I have g of x. So g of x is x plus 2. So I go ahead and put that in. So I have f of x plus 2. Okay, so just a direct substitution there. And now what this says is I'm going to put this x plus 2 as an input into f. And f says to cube the x, or the stuff. So in this case, I'm going to take this whole entire thing and cube it. Cube that input. So this would be our f of g of x. Okay, x plus 2 cubed. And from there you can do whatever you want with this. It's fine to leave it like this. You can expand it, or depends on the question. You might have like f of g of 3, and then you plug in 3 for x and take it from there. But this is the actual composition step. So if I see this notation or either of these, I immediately write it like this, because I think this makes it a lot more clear that we are plugging one function into the other. And this one says we're plugging g of x into f of x. So sometimes you'll have several functions kind of chained together in this composition pattern, in which case you start with the innermost function and you move outward step by step. So that would correspond to the rightmost function, and then you just move one function at a time leftward. And we'll work through an example. We'll add one more function here and work through that example, but that's the general idea. So you're just taking x plus 2 here and putting that as an input into f. Now I think what gets kind of tricky or confusing about this is that I want to focus more on this pattern, because you might see an x here, this x, and then you see x here. The variables themselves are not that important. They kind of are, but in this case, as far as the pattern goes, just remember that this entire thing represents an input. So this is more of a pattern. F of stuff is stuff cubed. Just because the stuff happens to be x plus 2, the pattern still holds. It's just stuff, which happens to be x plus 2 cubed. Okay? So this x plus 2 and this x aren't necessarily related related other than the fact that this is just the input. Okay, it's not necessarily like a one-to-one correlation. So you could do like a x star is x star cubed, and then x star happens to be x plus 2. Okay, from there you want to make sure you leave parentheses in order of operations. Put parentheses if you're unsure, because you can always, get rid of extra parentheses if they're redundant. But if you happen to just do like this is different. It's a different order of operations there, so that would be wrong. But it's stuff cubed. Here, I'd say it's basically just about, like we said, keeping the order of operations and being clear which function is the input and which is the one that we are inputting into. And yeah, I think as long as you take your time there and are comfortable with this pattern, I like this idea of thinking about it as stuff cubed, or f of heart equals heart cubed, because it kind of distances us from this idea of x, which can be confusing when you have x plus 2. So it is important that this whole thing is a function of x or whatever other variable we're working with. It is important to know, that we are working with the variable x, but when you're looking at the actual pattern, it's kind of nice to separate out that idea so you don't get all confused with all of these x's. Okay, and I think aside from that, as long as we're pretty careful with the algebra and the computations, I think you will be good to go. So before we get into more examples here, which we'll do here in a second, now that we kind of have this general big picture idea of what's going on, I wanted to kind of give you a little bit of food for thought, which is that now that we are putting g of x as an input into f of x, we need to consider the domain and the domains and ranges of these functions. The domain of a function is basically the set of all allowable inputs, or in this case x values. And by allowable, I mean we can't break math, and in this context we're always working with real numbers. So for instance, if we have 1 over x cannot be 0. X can be whatever we want, from negative infinity to positive infinity, but x can't be 0. Or if we're dealing with like a square root function, x cannot be negative, otherwise you have imaginary numbers. So it's going to be 0 inclusive from 0 to infinity. So we need to consider the domain, which is allowable inputs, in this case x values, but also the range, which is the set of possible outputs. And so for these cases, it's pretty clear, but sometimes we have like trig functions or other types of functions that we need to think about. What are possible inputs and what are possible outputs? And in this context specifically, notice that the range of g of x here, the range, which is the possible of outputs, needs to fit within the domain of f of x. When you chain it like this, or when you're doing composition, the possible outputs of g of x needs to be within the domain, the allowable inputs of f of x. And if that's not the case, then sometimes you need to limit g of x over a particular domain. I hope that makes sense. So this is just all so that we don't run into a situation where there's a possible output for g of x that is not allowed to be put into f of x, so to speak. Okay? But when you first learn about this idea, usually you work with more straightforward functions where the domains and ranges are from negative infinity and infinity. Like in this case, this is a linear equation, it's a polynomial, so we're good to go there. It's totally okay, but that's just something to consider should you work with this further in future classes or as you learn about other types of functions. So let me go ahead and add one more function here. for the sake of practice, let's just keep it all linear here, or like another linear one, but just where the domains are all negative infinity to infinity, and the ranges are also negative infinity to infinity. Okay, so let's just do some practice now to keep emphasizing this pattern. So we did f of x, and maybe we can do like a side-by-side comparison. So I'll go ahead and write this out again. F of g of x, which was f of x plus 2, which is x plus 2 cubed. So let's do g of f. So that's g of f of x. Okay, so this time we are inputting f of x into g of x. So f of x is x cubed. And so now we're putting this entire x cubed as an input into g. So if you need to like draw this out for yourself, it's totally okay to do that. Take x cubed as your input. So g of x says g of stuff is stuff plus 2. My stuff just happens to be x cubed. So I get x cubed plus 2. Okay, stuff plus 2. So f of g is x plus 2 in parentheses cubed, and g of f is x cubed plus 2. Okay, so we get two different values here. Very good. And so, like we said, we can compose multiple functions. F of g of h, like that, or like this. Again, I'm not a fan of any of this notation, but it's okay. I'm just going to do f of g of h of x. I just always do this straight away when I see this of thing, because this tells me that I have h of x. I work inward out, so I have h of x, and I'm going to put that as an input into g of x, and whatever I get there, I'm going to put that as an input into f of x. So I start from right and I move leftward. So h of x is 2x minus 1. So I'll do f of g of 2x minus 1. And then I do g of 2x minus 1. And g of 2x minus 1 is g of stuff is stuff plus 2. Stuff happens to be 2x minus 1. So I do 2x minus 1 plus 2. Stuff plus 2, literally. So then f of, I'm going to clean that up, that's 2x plus 1. And now I put 2x plus 1 into f. So f of stuff is stuff cubed. So stuff happens to be 2x plus 1. So I'll do 2x plus 1 cubed. And that's it. So this is our f of g of h of x. So note that we actually have a function of x here, but you might have some questions where you're asked to do f of g of h of, let's say, negative 3. So in this case, that just means you put negative 3 as your x, so you can take this thing and put negative 3 here. So that would be, what, negative 6 plus 1 is negative 5 cubed is negative 125. Or you can put the negative 3 as you go. So h of negative 3 is negative 7. Negative 7 plus 2 is negative 5. And then you do negative 5 cubed is negative 125. So you can do this as you go, or you can plug in your x value at the end. Just make sure you follow order of operations, and it should be the same idea. Okay, so it's okay to chain this kind of composition, and if you have taken or are taking calculus, you might kind of recognize this idea of chaining functions together. So let's do one where we compose a function with itself. So it's the exact same idea, but we put the function itself as an input into the x cubed. So in this one I have x cubed cubed, which is x to the 9th. And then if I did f of x, I would do x to the 9th cubed, which is x to the 27th, etc., etc. You can keep plugging that input in. And same thing for g of x. You just do x plus 2 plus another 2, so x plus 4, and that plus another 2 is x plus 6. We have a little bit of recursion here. So I think for now that covers the basics of this. Again, just making sure you work from the inner function outward one at a time, and just make sure you know which two functions you're working with. Input one function into the other, consider the domain and range, and I think you should be good to go. I hope that this was interesting, relaxing, kind of fun. If you want to do some more practice with me, I'd love to do that as well, but I just wanted to introduce this concept today, especially for our algebra friends here